There's a few other ways that questions dealing with empirical formula can be phrased. Let's look at a couple of them. All right, here's an example. A compound is 43.64% phosphorus and 56.36% oxygen. What is the empirical formula? Here they didn't give us grams, but instead what we're going to do is assume we start with 100 grams of this substance. If we start with 100 grams of the substance, and we know that 43.64% of its phosphorus, we're basically just getting rid of the percent and turning it into grams. Getting rid of the percent, turning it into grams. Now we could do just like we have been with empirical formula. We can take our grams and convert them into moles. So we do that for both phosphorus and oxygen. Now, just like before, we divide by the smaller number, the phosphorus. But when we divide by the smaller number, we don't get even whole number ratio. Instead, if we look at this, we get P1O 2.5. So we have a decision to make here. We can either 1, round off the numbers, or 2, multiply the entire formula to get whole numbers. In this case, what we're going to do, instead of rounding off, we're going to multiply this to get a whole number. What can we do to this whole formula to get it to a whole number? Let's multiply it by 2. We multiply it by 2, we multiply the p, so there's 2 p's, O 2.5, so we get an empirical formula of P2O5. This we'll see a lot, especially if it's like if you get 0.33 or 0.66, you would multiply by 3 to get rid of those. If we have 0.25, 0.75, we multiply by 4. Smaller than that is rare. Maybe if we have like 0.2 or 0.4, we might multiply by 5. Usually it'll be small enough at that point or close to a whole number that we'd round off. But when it's right in the middle, like 2.5, we multiply everything by 2 to get rid of that whole number, or to get the decimal number into a whole number. All right, let's look at another example. Caffeine has a molar mass of 194 grams per mole. It was determined experimentally that caffeine contains the following there. What is its empirical formula? All right, so just like the last one where we had percentages, we just converted them to grams. Just say, all right, I have 100 grams. Let's convert our grams into moles. So I did this for us. Again, just using the molar masses from the periodic table. Now we look for our smallest number of moles. We get our smallest number of moles, this 1.50 moles of oxygen, and we divide everything by it. When we do this, we don't get whole numbers, but these are pretty close. So in this case, we're going to round off. So we just rounded off to C4H5N2O1. So that is the empirical formula, but we're not done. We were asked to find the molecular formula. So what we're going to do is we're going to calculate the mass of the empirical formula. All we did here was just calculate how much 4 C's weighed, 5 H's, 2 N's, and 1 O. Just find the molar mass of the empirical formula. We're not done, okay. It told us that the molar mass was 194 grams. Basically, our empirical formula is the molecular formula is a multiple of our empirical formula. We might have to double it, triple it, multiply it by 10, whatever. The way that we can do this is by looking at the molar mass and the empirical mass. All we need to do is just divide those two. So here we see 194 divided by 97. So that's our molar mass that we were given. 97 is our empirical mass that we calculated. We get 2. So that means caffeine is 2 times its empirical formula. So we just have to double that. Don't make sure we double everything. Again, there is a 1 here. We don't draw it. Make sure you don't leave that as just O. So we get C, multiply it by 2, C8, H10, N4, O2.